Hey everyone, Eric asked me to create a little bit of a presentation. I just have one slide for you guys talking about the 3-minute all-out sprint test used to find critical power, and it also helps to find anaerobic capacity as well. I know he wants to implement it within soccer and maybe some other running sports where endurance is key. This is a really simple, easy test that can be done on a track. It takes about 3 minutes, very simple and easy to conduct. You don't need very much like materials or anything like that. No one needs to get hooked up to a monitor, and it gives you guys an idea of someone's both their aerobic performance as well as their anaerobic performance, as opposed to maybe doing like a Cooper's run test or a distance test and seeing how fast they can run, a certain distance. And that basically just gives us an estimated VO2 value. This kind of tells us a maximal sustainable pace, meaning the higher that sustainable pace is, the better of an aerobic athlete that they're going to be. And then there's this W prime value, which we'd say that the bigger that W prime is, the more of an anaerobic or their ability to sprint, the kind of athlete that they're going to be there. So I have this graph right here. Basically, with the 3-minute all-out sprint test, on the count of 3, 2, 1, go. Usually, what we use is we have there's an app called Sports Tracker. It gets about every 2 seconds gives us velocity data in kilometers per hour. You strap that around their arm, put their phone in their hand, something like that, and on the count of 3, 2, 1, go. They sprint, and so their goal is to basically burn through all of their anaerobic energy systems, which are quick energy systems. So we should see their velocity spike up high and then gradually go down, because they're obviously not going to be able to maintain that pace. And so within about 2.5 minutes or so, we should see them hit kind of a nadir or a kind of a plateau in their speed towards that last 30 seconds, meaning they burn through those anaerobic energy stores, and now they're trying to go as fast as they can, but the aerobic energy systems can only provide ATP or energy so fast, and so that pace kind of remains the same or might even slightly go down just a little bit. But what critical power or critical velocity, so critical power would be cycling, critical velocity would be running. It's that exercise intensity that can theoretically be performed without exhaustion and represents the maximal steady state for lactate and oxygen, meaning it's kind of that maximal state in which we have lactate production and lactate clearance, high levels of lactate. So you can see it's kind of this transition between this heavy zone and this severe intensity zone. As soon as we start hitting the severe intensity zone, that means we're going to have an excessive buildup of lactate, and that's what this W prime value is. It tells us that however high we go above, this critical power, we're only going to be able to sustain that intensity for so long. And so it's the idea that this right here, critical velocity or critical power, is kind of that maximum sustainable velocity that an athlete can maintain. And really what we end up seeing is typically anywhere between 45 minutes to an hour is what they can sustain at that pace. Here's lactate threshold down here. It's kind of that transition between moderate and heavy exercise. Lactate threshold is typically lower than critical power, or is always lower than critical power. And you'll hear people talk about, oh, well, we need to shift the lactate threshold to the right. The larger their lactate threshold is, or at greater velocities that their lactate threshold is, then the better aerobic performance they're going to be. Well, if we shift that curve, we're also going to shift this critical velocity and critical power, to the right as well. Because really, if we're thinking about, performing aerobic exercise for an hour or so, then this is kind of the pace that we want to be able to maintain, which is going to keep us competitive. And so when we look at this W prime, it's that finite capacity for running speeds above critical velocity. So that also gives us a measurement of anaerobic capacity. So now this gives you an idea of, okay, who's my guys that can, really sustain a high velocity for, an extended period of time. They might not be your sprinters, right? Okay, and then this W prime, the bigger this W prime is, that's telling you these guys are my sprinters. Okay, usually the guys that are your sprinters are going to have a lower critical velocity. Guys that aren't really your sprinters, they'll have a smaller W prime or D prime, but they'll have a higher critical velocity. And what we actually end up finding is that this is just one study, but there are others, that critical power is actually more significantly correlated to running performance, because really VO2 max eventually kind of plateaus, and there's a lot more adaptations that happen at the muscular level in which critical power is involved. So there's more adaptations that happen in endurance athletes that would make critical power more significantly correlated to running performance. So the 3-minute all-out sprint test is a great test to perform for athletes. Again, minimal equipment is needed. It gives you an idea of who would be your sprinters, who's going to be your, kind of more endurance guys, and it's just a lot quicker of a test, and you can get it done all just with an easy just phone app. Again, it's that Sports Tracker app. Okay, hopefully this helps, and good luck this season.